All right, imines are pretty cool because we can add stuff to our carbonyl that maybe you think that you can't. So instead of adding two nitrogens to you can replace one of the, or instead of adding a nitrogen in an R group, your R group can be an alcohol instead. That'll form essentially what's a hydroxylamine. We won't learn too much stuff about there, but it's still pretty cool. The other thing that we can do is we can add hydrazine, which is basically just two amines adjoined to one another. Right, catalytic amount of acid that'll kick out a water molecule to form this imine. And then the cool thing about this imine is that if you add some base, some hydroxide, and some heat, you'll kick off the nitrogens, and then you'll be left with an alkane. So essentially what we're doing here is a reduction, and this is what's known as the Wolff-Kishner reduction. Spelling his name wrong, but Wolff-Kishner reduction. And the really driving force of this is that you form some nitrogen gas. And so if you think about your nitrogen gas that you form, it's highly favored to form this gas. First off, nitrogen is very stable, right? It's got that nitrogen-nitrogen triple bond. So the enthalpy helps that to form. And then it's also a gas. So the entropy also helps, right? So both delta S and delta H really prefer this to go along. Overall, the mechanism is a whole lot of proton transfer steps. So go ahead, check out the work along for the most of the mechanism. But the end kind of step, or the last step, is that we have this negative charge on this nitrogen, and then it kicks down its lone pair there. And then we break this carbon-nitrogen bond, end up with a negative on that carbon, and then it just picks up an H from somewhere else. And then, of course, you're left with your nitrogen triple bond.